Welcome to Z. Today, we're embarking on an exhilarating journey through the cosmos to explore the incredible role of space probes in unraveling the mysteries of our solar system. These remarkable machines have traversed vast distances, sending back invaluable data that has reshaped our understanding of the universe and our place within it. So, fasten your seatbelts and prepare for a cosmic adventure as we delve deep into the world of space exploration. Hi everyone, I'm your name, and I'm thrilled to guide you through this fascinating topic. Space probes are the unsung heroes of space exploration, tirelessly gathering data about planets, moons, asteroids, and beyond. They help us answer profound questions. How did our solar system form? Are we alone in the universe? What secrets lie hidden in the depths of space? Let's explore how these robotic explorers have changed our understanding of the cosmos. Our story begins in the 1960s, a time of intense curiosity and competition known as the space race. During this era, the Mariner missions emerged as trailblazers in planetary exploration. Mariner 4, launched in 1964, made history as the first spacecraft to successfully fly by Mars in 1965, sending back groundbreaking images of the Martian surface. These early, grainy images sparked immense public interest and ignited a global desire to learn more about our neighboring planets. They set the stage for an era of exploration that continues to this day. So, what exactly are space probes? These sophisticated machines come in various forms, each uniquely designed for specific missions that push the boundaries of our understanding. Flybys. These probes pass close to their target, collecting data during a brief encounter. This approach allows scientists to gather essential information quickly and cost-effectively. For instance, the Pioneer spacecraft were instrumental in early solar system exploration, giving us our first close-up views of Jupiter and Saturn. Orbiters. Once in orbit, these probes can study their target from a stable position, continuously sending back data over extended periods. The Mars Reconnaissance Orbiter has been monitoring the Martian atmosphere and surface for over a decade, providing invaluable insights into seasonal changes, weather patterns, and geological features. It has even captured stunning images of dust storms and ancient riverbeds, helping to paint a picture of Mars' dynamic history. Landers. These probes land on the surface of a planet or moon, conducting direct analyses of soil and atmosphere. The Phoenix Mars lander, for example, studied ice and soil in the Martian polar region and provided critical evidence of water ice, essential for understanding Mars' potential to support life. Each type of probe plays a crucial role in our quest for knowledge, providing complementary data that enhances our understanding of the solar system. Now, let's discuss the Voyager missions, two of the most iconic spacecraft in the history of exploration. Launched in 1977, Voyager 1 and 2 were designed for a grand tour of the outer planets. Voyager 1 famously flew by Jupiter in 1979, revealing its dynamic atmosphere, intricate ring system, and the Great Red Spot, a storm larger than Earth that has raged for centuries. The data collected during this flyby changed our understanding of gas giants forever. It then continued on to Saturn, capturing stunning images of the planet's rings and moons, providing a wealth of information that scientists are still analyzing today. Voyager 2, on the other hand, made history as the only spacecraft to have visited Uranus and Neptune. It provided our first close-up images of these distant ice giants, revealing a wealth of information about their atmospheres, ring systems, and moons. Today, both Voyager spacecraft are traveling through interstellar space over 14 billion miles from Earth, continuing to send back data that helps us understand the boundaries of our solar system and beyond. Their journeys represent humanity's farthest reach into space, and their discoveries continue to inspire future generations. Now, let's turn our attention to Mars, often called the Red Planet. Mars rovers, such as Curiosity and Perseverance, have been at the forefront of our exploration efforts, providing unprecedented insights into the planet's history and potential for life. Curiosity, which landed on Mars in August 2012, has been tirelessly exploring Gale Crater. Equipped with advanced scientific tools, it analyzes rock samples and searches for signs of past water, which is crucial for understanding the planet's habitability. Curiosity has discovered evidence of ancient riverbeds, organic molecules, and seasonal methane fluctuations, raising exciting questions about the potential for life on Mars. Its discoveries have not only enriched our understanding of Mars, but also provided valuable context for the search for life beyond Earth. More recently, Perseverance, which landed in February 2021, is on a groundbreaking mission to search for signs of ancient microbial life. Its primary goal is to collect soil and rock samples that may one day be returned to Earth, potentially bringing back evidence that could change our understanding of life in the universe. Perseverance is also equipped with the Ingenuity helicopter, which has made history by achieving the first powered flight on another planet. This small but mighty drone has conducted multiple flights, providing aerial perspectives and scouting locations for further exploration. The combined efforts of these rovers have made Mars one of the best-studied planets in our solar system. But space probes don't limit themselves to just planets. They venture into the depths of our solar system, studying comets, asteroids, and even the icy moons of gas giants. For example, the Rosetta mission, which launched in 2004, made history by sending a lander, Philae, to the surface of a comet 67P/Churyumov-Gerasimenko in 2014. This mission provided unprecedented insights into the composition of comets, revealing that they contain organic molecules and water, crucial for understanding the building blocks of life in the early solar system. The New Horizons mission, which flew by Pluto in 2015, provided the first close-up images of this distant world. It revealed a complex landscape with mountains, plains, and possibly even glaciers, challenging our traditional notions of what constitutes a planet. After its historic encounter with Pluto, New Horizons continued to send back data about other Kuiper Belt objects, expanding our understanding of this mysterious region at the solar system's edge. The technology behind these probes has advanced tremendously over the years. With innovations in miniaturization, communication, and data processing, we can now send more sophisticated instruments on longer missions than ever before. These advancements enable us to gather unprecedented data from distant worlds, analyze the composition of atmospheres, and even search for potential signals from extraterrestrial civilizations. The scientific instruments aboard these probes are marvels of engineering, capable of detecting minute changes in temperature, measuring atmospheric composition, and capturing high-resolution images from millions of miles away. Moreover, the data collected by these probes fuels countless research projects, collaborations, and discoveries here on Earth. Scientists around the globe analyze this information to answer fundamental questions about our place in the universe. And the future of space exploration is incredibly promising. Upcoming missions like the James Webb Space Telescope are set to revolutionize our understanding of the universe by exploring the atmospheres of exoplanets and searching for signs of life. This powerful telescope will peer deeper into space than ever before, providing insights into the formation of stars, galaxies, and potentially habitable planets. Meanwhile, the Europa Clipper mission, slated for launch in the 2020s, aims to study Jupiter's moon Europa, which is believed to have a subsurface ocean beneath its icy crust. This mission could provide crucial insights into the potential for life beyond Earth and help us understand the habitability of icy worlds. Additionally, the Mars Sample Return mission will attempt to bring back samples collected by Perseverance, a monumental endeavor that could answer some of the most pressing questions about life on Mars. In conclusion, space probes are more than just machines. They are our eyes and ears in the cosmos. They provide invaluable insights into the formation, evolution, and potential for life within our solar system. Each discovery not only broadens our scientific understanding, but also inspires us to dream bigger and reach further. The universe is vast and filled with wonders, and with each mission, we take another step into the unknown. The work being done by scientists and engineers around the world is a testament to human ingenuity and the insatiable curiosity that drives us to explore. Every piece of data returned from these probes holds the potential to reshape our understanding of the cosmos. If you enjoyed this journey through our solar system and want to learn more about the wonders of space exploration, don't forget to like, subscribe, and hit the notification bell for more exciting content. We want to hear from you. What space probe fascinates you the most? What questions do you have about the universe? Drop your thoughts in the comments below. We'd love to engage with you. Thanks for watching. Remember, there's a whole cosmos out there waiting to be discovered. Keep looking up at the stars and join us next time for more adventures in space exploration.